All right, so here's some review notes on parallel circuits. So just be careful now. All the rules that you used last week for series circuits, remember, they do not apply anymore, okay? All right, so what makes a circuit a parallel circuit? Mainly, there are multiple paths, or sometimes we call them branches, okay? So anytime there's going to be a split of the current to another path or another path, that's what makes it a parallel circuit, okay? And you kind of say that because it sort of looks like parallel lines, right? So anytime that there's a split, see at all these junctions, there's going to be a split, okay? And then the current is going to come back together. That makes it a parallel circuit, okay? Describe what happens to the current. Okay, what I just said is at each junction, okay, basically the current is going to split, then comes back together. I'm going to say at the bottom of the branch. Not really the bottom, but okay, branches. Okay. All right, and so remember that total current, since it's splitting, in order to find the total current in parallel, I'm going to add the currents, right? So like if this one had like say 1 amp of current, 2 amps of current, and 5 amps of current, the total coming through the battery would be 8 amps, okay? Because 1 goes this way, then 2, then 5, okay? And more current is gonna go where it's easier, okay? So path of least resistance. You probably heard this like as a regular term in your life, right? So in this case, right, this path here where there's 5 amps of current, this resistor would be the smallest because more current is going to choose to go where it's easier, okay? This path here with 1 amp of current, that's going to be a high resistor. That's going to be a harder path to travel, so less current is going to go that way, okay? All right, what happens to the overall resistance? Okay, the resistance goes down as you add resistors, okay, which mainly because you're adding more paths. All right, so we talked about that last week in the wrap-up, so if you want to go back to last week's slides and rewatch some of those videos about parallel, you can do that, okay, but hopefully you got it. This is just a little recap, okay, right? More paths makes it overall easier to travel through the circuit. Okay. All right. Mainly you're going to use Ohm's law. Okay. For the total resistance and the total current. This is your number one way to find the total resistance is by using Ohm's law on that top row in the table, in the template. Okay. That is the main way that you're going to do it. All right. If you want to be fancy, you can use the resistance equation. Okay. Which is adding their reciprocals. All right, so if you're mathematically inclined and this doesn't look too awful for you, you could go ahead and solve for, right, RT by doing the sum of their reciprocals and then taking the reciprocal again, okay? You will not have to do this, though, okay? This is not ever going to be necessary to solve any of the problems that we're going to give you, okay? If you want to do it, you can, but you always will be able to just solve it this way, okay? Right, and then the voltage drop across each branch is going to be the same, right? Because that voltage has to drop, say, from 10 to 0, right? All of these are going to have 10 volts at the top because there's no other resistors up here. And then everything down here has to be 0, all right? So what that means is across each path, there has to be a 10-volt drop, right? Because the charges must go through that whole voltage drop, right? Dump out all their energy, all right, as it moves through the circuit. And since each individual charge, I'll put another color, okay, is only going down one path or only down this path or only down this path, they have to drop that entire voltage there. Okay, so remember the total is going to be the same in each branch.